In this video, we are learning about electric dipole. What is electric dipole? And electric field. Electric field at an axial point. At an axial point and equatorial point on a dipole. So this concept we are learning in this video. So what is dipole? What is electric dipole? Electric dipole in the sense of a pair of two equal and opposite. There are two charged particles. One is plus q and minus q. We have separated the distance of 2a. Okay. Then this we can call it as electric dipole. So electric dipole we are representing with the letter P. P is equal to q into 2a. So this is electric dipole definition. Okay. Now electric field due to an axial point and equatorial point of a dipole. How to define this? How to derive this? Let's say there is a dipole of small q and capital here plus q. Small q, minus q and plus q, we have separated 2a distance from the center point O. So from the center point O to small q, let's say that is a distance, and center point O to positive q, again that is a distance. Now on the axial line, which means on the same line at point P from the center line to that is, let's say, r distance, we have placed one more charged particle. Let's say this is plus positively charged particle. We placed at point P. Now point P, here let's say A point at minus q charge and B point plus q charge. And at point P, again we have placed plus q charge. Due to point P plus q charge, there is a repulsion forces and electric field E is equal to plus q, which is repulse. And point P positive charge on that small q, negative charge, there will be an attractional forces here. Let's say that is E minus q. Okay. Now electric field, we can write electric field due to charge plus q at point P. So E plus q is equal to 1 by 4 pi epsilon naught q by r minus a whole square into P cap. That is E plus q. All right. Now, the resultant electric field, again here E minus q you can consider. E minus q at the same way, 1 by 4 pi epsilon naught minus q by r plus a whole square. Because at the point P to center point, that is r, and again still up to minus q, that is a. R plus a is the total distance from minus q to P. At the same time, plus q to P, total length is r. In that from center point to plus q, that is a, the remaining length will be r minus a. So that is the distances we considered over here. Now, E axial line. E axial line, we can say that E plus q plus E minus q. So E plus q value how much? 1 by 4 pi epsilon naught q by r minus a whole square plus 1 by 4 pi epsilon naught minus q by r minus a whole square. So 1 by 4 pi epsilon naught or q by 4 pi epsilon naught if you take a common. So 1 by r minus a whole square plus 1 by r plus a whole square into p cap. So that is equal to q by 4 pi epsilon naught. Here take LCM. R plus a whole square plus r minus a whole square. R plus a whole square plus r minus a whole square by a plus b into a minus b, which is a square minus b square. So you can write here comparably r square minus a square whole square of p cap. Now a plus b whole square plus a minus b whole square formula, as you know, that 4ab at the same time. Comparably, q by 4 pi epsilon naught into 4ar by r square minus a square whole square into p cap. So here you can write 2pr or 2r into q. 2r into q, we can call it as a p. So here 2pa we can write it. 2pr we can write it. So that is equal to q by 4 pi epsilon naught into, I guess q won't come over here, 1 by 4 pi epsilon naught into 2pr by r square minus a square whole square into p cap. So finally, E axial line is equal to 1 by 4 pi epsilon naught into 2p by r cube into p cap, which is r is far greater than a. So this is on axial line. Now coming to equatorial line. The same electric field on equatorial line we will discuss. Now, let's say that at point A minus Q, at point B plus Q, the distance between that is 2A. So from center point to this length will be A, and at the same time this length also will be A. From center point to at a point P, that distance is, let's say, R. Now what about PB length? It look like a right angle triangle. Okay. And these two are the sides. This is hypotenuse. R and A. This value hypotenuse, as you know, that r square plus a square whole power 1 by 2. R square root of r square plus a square. At the same time, AP distance also r square plus a square power 1 by 2. Now, there is a positive charge we have placed at point P. These two again the repulsion. So electric field over here in this direction E plus Q. Now this is minus Q and this is plus Q. There are the attractional forces over here, that is E minus Q. So the resultant will be E effective. All right. Now, electric field at a point P due to plus Q. So E plus Q is equal to 1 by 4 pi epsilon naught into Q by r square plus a square along BP direction. Next, electric field at point P due to minus Q. So E minus Q is equal to 1 by 4 pi epsilon naught into Q by R square plus A square. So which is along PA. Now finally, both are same. E plus Q is equal to E minus Q, that is equal to 1 by 4 pi epsilon naught Q by R square plus A square. Alright. Therefore, we can find out E equatorial. So, E equatorial line, I can change the color of, yeah. E equatorial line is equal to minus of E minus Q cos theta plus E plus Q cos theta into P. That is equal to, both are same. So, minus 2E minus Q cos theta, okay, into P cap. That is equal to minus 2 into 1 by 4 pi epsilon naught into Q by R square plus A square into A by square root R square plus A square into P cap. So as you know that cos theta is equal to A by square root of R square plus A square. Finally, E equatorial line is equal to minus 1 by 4 pi epsilon naught into P by R square plus A square power 3 by 2 into P cap. So this is equatorial line. Thank you so much. Keep tuned for the next theories.